Today we're using this gadget, which is called a vector network analyzer, to test a bunch of antennas on 2.4 gigahertz. So what this is, you can see it's got a few buttons. Connect your antenna on the top there, can you see that? Let's see if that's in shot. So I'll put this is a standard antenna that comes with a orange module, I think, on there. And there's two main screens that we're interested in. One is this sort of detail screen that shows you a bunch of parameters like the VWSR, the standing wave ratio, and also impedances and things. But probably a more interesting screen for us is this one. Here you can choose to display various things, but at the moment it's showing the standing wave ratio, VWSR, and it's scanning between 2 gigahertz and finishing at 2.7. You can see those figures down in the down towards the bottom of the screen. So if I move this, sorry, I've altered it from standing wave ratio, which I didn't mean to do. Let's get back to that. Right, if I go to this marker, I can move that up and down and see the current frequency at the top. We can see that the lowest point, which is what we're interested in, is about 2410 megahertz. So I'm now going to alter the scan to go from, let's go from 2.4 just up to 2.5. So we've zoomed in a lot now, and now we really need to alter the scale of the thing, which is this one. .4 is probably a bit too low a starting point, so I'll alter that to, I don't know, 2.35 or something like that. Okay, so now if we look at the minimum, we can say it's about 2.408. I'll go back to the other screen and I'll adjust this till it is on 2.408, and then we can see the figures for this antenna at roughly its minimum. So you can see that the VWSR is 1.06, that's very good. The impedance is about 50 ohms, which is what it should be. So that's very good indeed. Now then, obviously the way this is working is it's transmitting a weak signal into the antenna and measuring how much power is reflected back. So it's interesting to have a look at the signal on this little frequency scanner thing. I don't know if you can see that, and you can see it really is at 2.408, and if I go to the other screen, you'll see now that it's scanning, and if I set the start and end points to, I don't know, 2.4, let's set it to 2.43 and 2.47. So what did I say? 2.43 to 2.4 7. And you can see now on the frequency scanner that it's only scanning that little bit of the band. Again, if I go back to that screen, now it's just transmitting one big signal on this 2.408 frequency. Okay, so that's just out of interest really. So now let's start checking the antennas. So what I'm going to do is set the band quite wide again, because we've got a bunch of antennas to check and we want to see what frequency they're on. So let's go up to 2.65 as the top one, and we'll go down to 2 gigahertz for the bottom. So the antenna that's on there at the moment, as I say, it's got that tape wrapped around it, but that's just the mechanical problem. Inside it's actually very good. Now let's have a look at some others. So these are some antennas that have been sent to me by Paul to be checked. Now let's try this one first. And he's labelled this one old thick cable 3131. I think that's the length of the sleeve and the length of the whisker. You see on that part of the aerial there. And you can see at the moment it's saying that this is terrible, or we're looking at the wrong part of the range. So let's change the range, and we go for that one, X1, X2, and I think we need to go over a bigger range, so we'll adjust the not that one, the start frequency down lower. So now we're scanning from 1.8 gigahertz up to 2.5. It looks as though the minimum is, well, let's see, I'll move that pointer back to the minimum. Oops. About there. So it's about 2.06. So to zoom in on it, I want to set the start frequency to 1.9. and the finish frequency to 2.1 or thereabouts, maybe a bit higher. That's it, we seem to have the minimum on the screen now. I'll alter the range. Yeah, that's probably the best picture, isn't it? And we'll move the marker to be at the minimum. So we can see the minimum is about 2.05, and we've got a standing wave ratio of about 1.6, which is not bad. Now this antenna, to work on the 2.4 gigahertz band, we'd have to trim it down a bit, but that's to be expected because it is 31 millimeters long, and the figures for the to be good on 2.4 gigahertz are supposed to be around about 24-26 millimeters, something like that. Okay, that's one antenna. Let's move on to another one. When I've checked, Paul's got 4 antennas to check, and when we do those, I've got one I've made myself, and we'll trim some little bits off that one until it comes into resonance at the frequency we want. So this is another one, and this is labelled thin cable 2626, so we'd expect this to be somewhere up around 2.4 gig. But it doesn't appear to be. So again, it looks as though the low point is off to the left of the screen. So let's go and alter the start frequency to be 1.8 something. And we're going from 1.85 megahertz now up to, oh no, it's not as bad as I thought, sorry, my mistake. There we are, having to go up to 2.7 now. I've got, the trouble is I'm touching the area with my hand, but if we look at where the minimum is now, and then I'll zoom in on that area. So the minimum's about there, take my hand away, it's at 2.33, so again not bad. So I'll tighten up the scaling by going from 2.2 up to 2.4. So what did we say, 2.2 up to 2.4. We can alter the scale a bit to make it fill up more of the screen. That's probably the best one, isn't it? And the minimum now is, whenever I put my hand near the aerial it moves a bit. I'm just going to go down a fraction. Maybe there. So that's 2.323. So that's just below our band, which starts at 2.4. So that one could do with being a tiny bit longer. Okay, that's 2 down, 2 to go. Now the other 2 have got I don't know if the camera will focus on this, but these have got what's called a SMA connector with a pin in the middle, and the other 2 have got an RP SMA that's got a hole, so we need an adapter. And I've got an adapter here, not a very good one, so this will probably introduce some loss into the circuit, but shouldn't alter the resonant frequency, which is what we're really interested in. So this one is labelled thick cable, 26mm whisker, 24mm tube, and this was Phil's recommended sizes to be spot on, although we may not have the right diameter tube, I'm not sure. Okay, so that's interesting. Let's begin by widening the the band we're scanning over, because there appears to be 2 minimum there, doesn't there? So we'll go from 2 gigahertz all the way up to 2.7. Now, as I say, maybe this is some artifact of my adapter, but if we go and have a look at what the 2 minimum are, we've got one about there. Where is it? It's moved now. Ah. Sorry, I'm moving the wrong thing. 2.7, and I'm trying to move this little yellow triangle to get it down to that minimum, roughly there. So that's 2373, which is still just below our band. If I get up to 2.4, that's 2.403 where the little yellow triangle is now. And then we've got this other interesting minimum down at 2.203 gigahertz. Okay, well, onwards. I'll tell you what, I'll put a commercial antenna, this one, which is a RP-SMA, on the adapter, just to see if it's the adapter that's causing the problem. No. So there we've only got one minimum, and we can see it's at about 2.4, what's that, 2.4 something 3. I'll go and, well no, I won't zoom in, but we can see that one's only got one minimum, whereas this one we were just using has got those two. It's very odd. I don't really understand that. Okay, we'll check the last one and then we'll move on to the one that I'm going to trim back. So this one is labelled thick cable, 26mm whisker, 26mm tube. And again it's an RP, SMA RP, so we need the double, we need the adapter, and again it looks as though we've got a double minimum. That one is about 2 SWR, occurring at 2.293 megahertz, and then the real lowest one is at 2.133 megahertz. So I say it looks as though that really is what these antennas are doing. I mean, to put it in perspective, if we come up to 2.4, which is where we really want to be, now I've moved the triangle up to 2.41, and there we've got a standing wave ratio of about 3.2, which is not terrible. It would work, but again, if I put this commercial antenna back on the same adapter, now we've got a standing wave ratio of, what's that, 2.6, something like that, and it's at the right frequency. I say the fact that it's 2.6 rather than nearer to 1 is probably something to do with the adapter not being ideal, but the fact that there's 2 dips rather than 1, I'm not really sure about. Okay, now let's do the thing where we can get rid of the adapter because the one I've made is, if I can find it, here we are. This has got an ordinary SMA connector on, so we don't need to use the adapter. You can see we've only got the one null, and it's very good. It's coming down all the way to the standing wave ratio of about 1, and that's at a frequency of 2.453 at the moment, which is not bad. I'm surprised actually, because I deliberately made the whisker a bit long, but just to demonstrate the effect of snipping a bit off, you can see that's 2.453, and if I can get it into shot, I'm now going to nip a millimetre or so off the end of the whisker with these cutters. And you can see that's moved the resonant frequency up to 2.513, which is what you'd expect. The shorter you make the antenna, the higher frequency it resonates at. So this is a homemade one. We've got 2.523, that is, as a minimum. So if I go and alter this to 2.523, we can see what it actually says for that. So it's 45.2 ohms and a VSWR of 1.123. And this antenna, we can just see if I can get the camera to focus on it. Probably a bit difficult on this background. Let's put something a bit darker under it, see if that helps. There we go. So all it consists of is a bit of tube, which is that's this thing. This bit of tube here was cut off an old transmitter aerial, and that's about 24mm long, and it's soldered to the outer coax, and then the whisker sticking out the end is longer than what the theory said it should be, because I made it 30mm to start with, and now I've chopped about a millimetre off, so it's still 29mm long, and yet as you can see we're working very well at 2.523. And I think the theory says cut them to 26mm long, but if you do that, then apparently they're resonating at too high a frequency to really be in the middle of our band. Okay, well, I've waffled on for long enough. I'll put this up on YouTube and see what your comments are. Thank you.